For problem number 19, we need to determine the average length of fish over the first 3 years of its life. What we know is that the fish starts its life with a length of 1 centimeter, and we also are given the growth rate. So the growth rate, R of t, equals 29 e to the power negative t over 2. This is in centimeters per year, and t is in years. The starting length of fish, let me denote L by L, the length of fish at the moment of time t. So L of t is the length of fish. T years after birth. Then the information that we have that it starts its life with a length of 1 centimeter basically means that our function L of t has the value of 1 when t is 0. And the question is, what is the average length of fish over the first 3 years of its life? So first of all, let's determine a function that's going to give us the length of fish t years after birth. In other words, let's determine what L of t is. Okay, well, so after 2 years since birth, the length of fish will be 1 centimeter that it started with, plus whatever additional length that it acquired in t years, plus growth amount. In t years. Now, how can we find this growth amount in t years? Well, we're given the rate of change, rate of growth, and therefore, by the fundamental theorem of calculus, we can determine the total growth amount over a period of t years by integrating the growth rate. So there's our growth rate, R of t. And so I'm going to write this as 1 plus integral from 0 to t. Now our growth rate is expressed as a function of t. Since I'm using t as an upper limit of this integral, I'm going to change the variable of integration just to another letter. It really doesn't matter what letter we use. I can, for example, use x. So that formula that we had earlier for the rate of growth, R of t, I'm going to use there x instead of t. So it's going to be 29 e to the power negative t over 2. So I'm looking at this growth rate. And instead of using t, I'm going to use x, right? And the only reason I'm doing this is because in the integral that I've written now, I'm using t for the upper limit of integration. So in order to avoid the confusion where letter t is used for two different things, I'm going to use x for the variable of integration. So we need to integrate 29 e to the power negative x over 2 dx on the integral from 0 to t. Now let's calculate what that gives us. In order to make this in order to calculate the integral, we're going to make a substitution. Namely, u is going to be negative x over 2. If we calculate the differential of u, we're going to get negative 1/2 dx. Solving this for dx, we find that dx equals negative 2 du. And we will also need new limits of integration. So let's calculate the values for u when x ranges from 0 to t. When x is 0, u is going to be negative 0/2. That's also 0. When x is t, we're going to get that u is negative t/2. Right? Okay, so now I have everything ready to make our substitution. I'm gonna get 1 plus integral from 0 to negative t/2, and I have 29 e to the power u, and then instead of dx I need to put negative 2 du. Very good. So now I get 1. The constant negative 2 and the constants negative 2 and 29, these factors can be pulled out of the integral. 2 times 29 is 58, so I'll have minus 58. Integral from 0 to negative t/2 e to the power u du. And this is now easy to integrate. Antiderivative of e to the power u is e to the power u, so we get 1 minus 58 e to the power u, where we evaluate this antiderivative at 0 and negative t/2. And so we're going to get 1 minus 58, open parentheses, e to the power negative t/2 minus e to the power 0. E to the power 0 is 1, and so putting all of this together, we're going to get the following formula for the length of fish at the moment of time t since birth. 59 minus 58 e to the power negative t/2. Where does the 59 come from? It comes from 1 on the left hand side here, and it also comes from the 58 in addition to 1, which will come from negative 58 being multiplied by negative 1 here. Okay, so now we have formula for the length of fish at the moment of time t. Then I don't have much space left here in this slide, so let me go to the next one. And I'm just going to copy this result that we've calculated the formula for the length of fish t years after the birth. 59 minus 58 e to the power negative t/2. Now, the problem is asking us to find the average length of fish over the first 3 years of its life. So t is going to range from 0 to 3, and we want to know the average value of this function on the interval from 0 to 3. Let's recall how we find the average value of a function on some interval. So let's say we have a function f of x. Let's say x ranges on the interval from a to b. Then the average value of this function, f of x, on the interval from a to b, often denoted by f bar, can be calculated as the integral from a to b f of x dx divided by the length of the interval of integration, b minus a. In the textbook, you can find a really good explanation of why this formula is used to calculate the average value of a function. It's really a substitute of a formula that we use to calculate the average value of finitely many numbers, where you add them up and divide by the number of terms that you add, the number of numbers that you include. And really this is a natural extension to the case where your function has infinitely many values, as of course a function on the interval from a to b would have. So in this case, the formula becomes that formula that we use for finitely many values turns naturally into this formula with integral. How does this apply to our situation? Well, the average length of our fish on the interval from over the period of the first 3 years can be calculated by integrating its length function from 0 to 3. And so it's 59 minus 58 e to the power negative t over 2 dt. From the interval from 0 to 3, and then dividing by the length of the interval of integration, which is of course 3. Now the integration is not complicated. The antiderivative of 59, first of all, dividing by 3 I'll put in front as a constant 1/3. Then the antiderivative of 59 is 59t. You can make a substitution, u equals to negative t over 2, and work out your second part of your integral of your antiderivative. I'm going to write the answer. The answer is going to be 2 times 58 times e to the power negative t over 2. And we need to evaluate this antiderivative at the endpoints, 0 and 3. Okay, so let's see what we get. I get 1/3, and then when we plug in 3, we're going to get 59 times 3 plus 2 times 58 times e to the power negative 3 over 2. And from that I have to subtract the value of the antiderivative at 0, so minus 59 times 0 is 0, and then 2 times 58 times e to the power negative 0 over 2, that's going to be 2 times 58. Okay, now we can plug this into our calculator and calculate our final answer. Let's go to our calculator. So I have 1/3 times 59 times 3. Then I have to, let's see, I have to add 2 times 58 times e to the power negative 3/2. And then I have to subtract 2 times 58. There is something wrong here in the formula. I think I placed closing parentheses not where I should have. And that gives us the answer. Now, looks like I'm getting a slightly different answer. That is the answer in the problem. Let's take a look. Let's see, maybe I made a mistake somewhere. I'm sorry, this is a wrong. Lost my notes. Oh, here it is. Okay, I think we're on this slide. Okay, just double checking the calculation here. All right, let me pause the recording until I can figure out what's going on here. Okay, so I've looked into the problem in more detail, and I actually see that I made a typo in the problem. I apologize. The growth rate should have been 29 e to the power negative t for this fish if it has a maximum length of 30 centimeters. So I had a typo. Now, with the way the problem was formulated, the correct answer would have been the one I've calculated here in the solution. So I don't see any mistakes in the solution that I presented here. And so if the growth rate were indeed 29 e to the power negative t over 2, then the correct answer for the average length of fish over the first 3 years of its life would have to be 28.96, or if we round to the nearest integer, it would be 29 centimeters. My apologies for this mistake I made.